So as we're aware, the problem with lithium-ion batteries is not limited to Massachusetts and is a worldwide problem. By sharing our experiences, investigating, and documenting these incidents, as we have just learned, we may be able to identify trends and hazards and establish recalls. To discuss what is going on nationally and to let us know what services may be available, please welcome from the United States Consumer Protection Agency, Product Safety Investigator, Sara Cadden. Keep it in front of you.
Okay, and then let's just press the right button.
Yes.
Okay, great. All right. Thank you, everyone. Just to kind of piggyback real quickly on the unfairs reports, we utilize those in a lot of our investigations when there's not a formal investigation report for an incident or a fire. So that product detail, if you can get any manufacturer's information, model number or anything, is very critical to our investigations. As I said in the introduction, our agencies are responsible for regulating, creating all the safety regulations for products. We regulate over 18,000 products for United States consumers. We also are responsible for all the nationwide safety recalls, product safety labeling, and then safety notes in the owner's manuals for products. Yes, we are out of Washington, D.C., but I'm right in Westminster, Massachusetts, so I'm available to all of you at any time. So let's see. So this was we have a couple case studies for you guys to kind of show how our investigations go from start to finish. A lot of times we'll get tips from fire departments, just heads up from you guys directly. You can report it on an incident on our website, saferproducts.gov. You can email me or call me directly, to see if I'm interested in obtaining the product sample or your report, or once a year we do get the unfairs reports. For this one, it was a news article. We also get cases from the coroners, police, and news scans where a lithium-ion battery caught fire on an airplane. So we became aware of the incident, and so it was on the news, so therefore it was high profile. FAA had the sample product. Multiple agencies were involved. The FAA standard, a different agency than ours, is to submerge the product, the lithium-ion incident sample in salt water, so that's what they did. We weren't able, after the plane, we weren't able to get there until the following day to get clearance from FAA, so we weren't able to interview any of the witnesses. So therefore, some of these, as you can see, the scene was secured. So only person we were able to interview was the owner of the phone, and we were able to secure that phone after the FAA cleared it and completed their investigation. So sometimes, as you guys can see, what we can have access to is very limited. Sometimes it's just the product sample or just the unfairs report. Sometimes, when we can get our interviews, that's very valuable. But in this situation, it was very minimal. This is what we received. It was a carry-on laptop bag. It was, a phone in a laptop bag. And the consumer opened the front pocket of his laptop bag, grabbed the power bank, and tossed it to the aisle beside him. We noticed it was smoking. It combusted and fell into two pieces. And then the flight attendants used a fire extinguisher. And it happened luckily on the ground. So this is the salt container that it was stored in until we could collect it. And this was all we received for the product. As you can see, it's probably very difficult to identify that. In many of your instances, you guys may dispose of that. But we were able to complete this case just using that charred little mess for that power bank. So these samples are really critical to us, and it also helps you guys to kind of get rid of some of these hazmat products. I'll touch more on that in a minute. So we were able to get the phone. We also will go out and purchase exemplar samples, which I'm sure you know are brand new samples of the exact same model. So we can compare them at the lab. As you can see on the right here is our exemplar sample. We ship everything hazmat, so we have the static-free bags for the incident product. The one on the left, as you can see, of course, is our incident product. That's all we have, but we do have an X-ray machine in our lab to identify that this is the exact same product. And so we can see the internal dynamics. Our lab has a phenomenal engineering department and legal team as well. So I'll complete my investigation. It goes on to our lab. The product will be analyzed by the engineers, and then the legal team will go after the manufacturers. I'm sure a lot of you guys already know how a lithium-ion works. There's a negative anode, which is the red, and then we have a positive cathode. They must be aligned properly. So a lot of these fires that we're seeing in our lab, when you're seeing a thermal runaway, is because these end, I'm not sure how the laser works, these end materials are not lined up properly, and you'll see that in a couple x-rays I have in some slides from some of our cases. So there's a separator, as you guys can see in the blue. That's what keeps them shorting. If the cathode, which is the yellow, which is your positive, comes too close to the separator, it can cause a short in that situation where there's not physical damage. Obviously, if it's punctured, we all know that the positive and negative are touching. But a lot of the times, like we'll see in nearly every single one of our cases where the product was just charging or it was just sitting there on the sidewalk and caught fire, that these anodes and cathodes were not the same length, and so therefore they came in contact or came too close. This releases a lot of energy when there's contact at a fast rate of speed, which creates heat and ignites. The misalignment of layers, that's what I was talking about. So that's kind of how that works, positive and negative in the spacer. And again, like I said, if anything's punctured, that spacer, that blue line, of course, will allow that contact. This is what I was talking about. As you can see, so this is the end of the battery of a lithium-ion battery. So you can see where it's not even and smooth, it's rigid. That's showing that that's how a lot of those thermal runaways occur when the product is just sitting there or just charging, because those positive and negatives are up past the separator and can create contact and create that thermal runaway. And like I said, in nearly every single investigation for thermal runaway, for a product just sitting there charging, this is the cause, when there's not damage to the battery. Here's a second case study, second of two. We have another power bank. Sorry to be repetitive, but it's just an easy case here that were recent. Oh, sorry, this is the first one. This is the airplane one we just discussed. After the x-rays, we determined that was the cause, and this resulted in 190,000 portable power banks being recalled. This is an Amazon purchase, not a well-known brand, which I'm sure you guys have seen. My second case study, here we go, I apologize. Another airplane, which again, we don't have that many on airplanes, but that's what the engineer sent me here. These are just great case studies showing lithium-ion. This was another power pack stored in the overhead bin, started smoking, again, while they were on the ground. He had 2 battery packs in his bag. Both were turned off and stored in the mesh luggage up in the overhead bin. They noticed smoke. The bag was pulled up by a passenger who was a firefighter. So another case, the consumer reported that where he purchased it. He had no idea what the make or model. So then it's like, okay, was this case going to be a dead end? But luckily, our labs are fabulous. We secured that incident product. We follow all hazmat shipments for DOT and UN regulations, so it's difficult to ship them, as you guys know, and expensive. But we do the static-free bags. We have to ship it hazmat, so therefore no bridges and ground only. So it's a process, but we safely ship these products after they've already been through thermal runaway to our lab for studying. So these are the 2 power packs he had. The one on the left in the blue is one of those charging stations where you can just put your phone on it, and we know that because of the silver ring, and also the lightning bolt image. The one on the right is just a plug-in portable power station. So as you can see, the one that did not cause a thermal runaway on the left, you can see the ends are smooth, everything is tight. There was no uneven anodes or cathodes. And you can see the one that went under thermal runaway. Here's the x-ray after the incident, just showing that everything was uneven and the space isn't consistent. And so as you can see, obviously, this was the one on the left that did not fail was a well-known brand. And then the one on the right was a lower cost product purchased from an online retailer. This is something I stress. It's so important. A lot of times you guys, or I shouldn't say you guys, excuse me, fire officials will just say, well, we tossed the product. It was a smoldered mess of nothing, and you wouldn't be able to get anything from it. But in this case, this was that power bank I showed you in the previous slide, where in our lab, they'll clean the product, they'll heat it, and then they'll unwrap it. So in that case where it was this smoldered mess on the right, as you can see pointed at the red arrow, They were able to clean it, unwrap it, and identify manufacturer, model name, and serial number. So therefore, we were able to go after the manufacturer, which is great. And it was great that you guys, or the fire department, was able to get us the sample. So again, we'll purchase exemplar samples. In this case, we purchased 14. We'll do stress tests and charging tests and x-rays and everything to try to create that thermal runaway again in our lab, which we were able to conduct. This is that same power bank. You can see the x-ray. This was one of the exemplar samples. These had not been through thermal runaway. You can see that the ends aren't as smooth and nice as that previous one I showed you. And it wasn't all 14. So therefore, showing that anodes and cathodes are misaligned in both cells. These are just brand new exemplar samples. So when there was 350,000 portable power banks, this resulted in this recall. And that was just from one lithium-ion battery runaway. It was not like we have to collect data and we don't act on until there's an X number. If there's just one that we see it's a product and it fails and we test it, for that example, there was just one incident. When we purchased 14 exemplar samples, we saw an issue in every single one of these lithium-ion batteries. So yeah, here's a safety recall. So it's really beneficial to have those product samples. If you guys just give me a call, my business card, and I have a whole bunch of pamphlets on the back desk, so you guys can contact me at any time. Let's see, I have a couple of off-slide things. So the percentage of overall fires is small compared to the number of lithium-ion batteries out on the market. Thank goodness, but as you guys know, that's going to rise as products continue and more products are shipped over from China. We absolutely can regulate the labs in China, the factories in China, because we have investigators who just sit at the ports and inspect the products that come in to determine that they meet our safety standards for these kind of products. So we can ban Chinese factories. Of course, that doesn't stop them from opening a new factory, but we can go after products or manufacturers overseas and prevent them from make them aware. They have to have certain inspection processes and documents in order to come into the country. The majority of my lab saw incidents, lithium-ion incidents, were during charging. They, of course, recommend using compatible chargers and purchase chargers directly from the manufacturer to avoid counterfeits or features that can cause failures. For example, voltage. A lot of the investigations I do with lithium-ion batteries are because people are buying chargers that aren't compatible with the voltage of that lithium-ion battery, or purchase from a third-party trusted source. So that's about all I have, trying to keep it nice and short for you guys. I know grants is up next, and I just kind of wanted to quick touch that we do have a federal grant for any fire department that installs smoke alarms. There's $2 million on the table, and it expires December 15th. So email me, and I can get you the link to that. But that's all I have.
Thank you.
Thank you.
Thank you very much.